All right, guys, welcome to section 6.1. We're starting trig. Today we're doing angles and their measure. So we'll cover decimals to degrees, minutes, seconds, and reverse. We'll do arc length. We'll do conversions from degrees to radians and backwards. We'll do area of a sector and an angular velocity problem. Okay, so first of all, let's talk about angles. When we say an angle is in standard position, its vertex is at the origin, its initial side is always on the positive x-axis, and its terminal side can be anywhere else. So this would be an angle in standard form, standard position. If it is going counterclockwise, we call it a positive angle. Now this one, the initial side, again, is always on the positive x-axis. This time we went clockwise to get to the terminal side. If we go clockwise, we call it a negative angle. Okay, so the first couple examples, I just want you guys to sketch each angle in standard position. So for example, number 1, just draw a simple XY axis. And if you're sketching 40 degrees, the initial ray will be here, and then up 40 degrees would be a little less than halfway. So that would be about 40 degrees. Okay, number 2. Now this one says negative 90. So again, the initial ray will be on the terminal, or on the positive x-axis. And then since it's negative, we want to go clockwise. 90 degrees is just right here. So that angle would be negative 90. 225 degrees. Let's see. Again, always start with your initial ray on the positive x-axis. 225 is 180 plus an extra 45. So that would be angle 225. And then lastly, 405. Well, that's going to be a full 360 plus an extra something. So it's going to be a full 360 plus an extra 45, right? So a full 360 plus an extra 45. That'll get us to 405 degrees. Okay, cool. So that's just sketching angles. Okay, converting between degrees, minutes, seconds, and decimals. So here's what you guys need to know on this one. I'll write it off to the side. 1 degree is 60 minutes, and 1 minute is 60 seconds. And then let's also go backwards. 1 minute is 1/60th of a degree, and 1 second is 1/60th of a minute. Oh. Yeah. Sorry. 1 minute is 1/60th of a second. I think I said that in reverse. Okay, so let's try it here. So if we give you a decimal in degrees, can you convert it to just a decimal, not minutes and seconds? Okay, so let's see. We know it's going to be 50. Now let's see. If it's 6 minutes, how many, what is that as a decimal? So we're going to multiply 6 by 1/60th of a degree. And then plus, now we have 21 seconds. And 21 seconds is 1/60th of a minute, but then also another 1/60th of a degree. So I'm just going to do squared. Okay, so it's the full 50 degrees. 6 minutes is 1/60th of a degree. 21 seconds is 1/60th times 1/60th of a degree. So that's why I squared it. And then this you guys can just type in the calculator. All right, so it's 50 plus 6 times 1 over 60 plus 21 times 1 over 60 squared. And then it says round to 4 decimal places, so we can put 50.1058 degrees. Okay, so written as a decimal. Now, B is just going backwards. They want you to convert the decimal form into degrees, minutes, seconds. Okay, so obviously we know we have 21 degrees. Now let's work with the decimal that we have, 0.256. Let's go ahead and multiply that by 60 to see how many minutes we have. Okay, we get 15.36. So I'm going to say that's going to give us 15 minutes, or wrong symbol, 15 minutes. And then that remaining 0.36, we're going to multiply that by 60 again to see how many seconds we have. So the 0.36 times 60 again, and that's 21.6 seconds. But it says round it to the nearest second, so let's round that to 22 seconds. So final answer, we have 21 degrees, 15 minutes, 22 seconds. There's also a button on the calculator that will do this for you, so we can talk about that in class. All right, so now that you guys have mastered degrees, let us switch over to radians. Okay, and the cool thing about a radian, it's also talking about angles, but it's also talking about the radius, the length of the radius. So when the length of the radius is equal to the length of the arc that is created by the two radii, this angle is called 1 radian. Okay, so again, a radian is when the arc length is equal to the radius length. And it turns out that 180 degrees is equal to pi radians. Okay, that's going to be a big formula for you guys for this conversion section. Okay, so if you want to convert degrees to radians, we're going to multiply 60 degrees by the conversion. There's pi radians in 180 degrees. Okay, and we're going to cancel the degrees and reduce. These cancel. And then if we reduce 60 by 180, that reduces to 1/3. So the answer is pi over 3. And I'm not going to write radians every time. So 60 over 180 is 1/3, and then it's pi, so pi over 3. Okay, same thing here, negative 45. So I'm going to write negative 45 degree. The conversion is that there are pi radians in 180 degrees. And then just go ahead and reduce 45 over 180, and that reduces to 1/4. So this ends up being negative pi over 4. Okay, and then C, same thing. 107 degrees converted to radians. The conversion is that there's pi radians in 180 degrees. I don't think this reduces at all, so you would leave your answer as the fraction 107 pi over 180. That's in radians. Now to go backwards, we do the same thing, but we'll flip the conversion factor. So if you're given pi over 6 radians, you're going to multiply by not pi over 180, but 180 over pi. Because that way the pi radians will cancel and you'll end up in degrees. Okay, so 180 over 6, that's 30 degrees. Same thing for B. Let's start with 3 pi over 2 radians, but our conversion now is 180 degrees in pi radians. And in this one, the pi's cancel. And 3/2 times 180 is 270 degrees. All right, last one. 3 radians. Again, if we're converting to degrees, there's 180 degrees in pi radians. Now, this one didn't have a pi to cancel, so we actually just have to calculate it. So you're going to do 3 times 180 divided by pi. And that is 171.89 degrees. I'm just rounding to 2 decimals. Okay, so when the pi's cancel, it's kind of nice. But if not, just calculate it. You'll get a decimal. Okay, some other big formulas, and then you guys are done. Let's go over what these stand for here. So S equals R times theta. The S stands for arc length. So let me write that down. So if you want to find the length of an arc, it's equal to R is the radius, and theta is the angle in radians. Okay, so you have to convert it to radians first. And then the next formula is there's 1 revolution is 2 pi radians. We're going to use that one soon. The area of a sector of a circle is 1/2 r squared theta. Again, where r is the radius and theta is the angle in radians. And then lastly, v is the linear velocity. R is the radius. And this little W looking thing is the angular velocity. Oh, you guys can't see that. Angular velocity. Okay, let's go for it. So, example 1. Find the area of the sector of the circle with radius 2 formed by an angle of 30. Round your answer to 2 decimal places. So, I'm going to draw a picture. And let's say we have a 30-degree angle. The radius is 2. Find the area of the sector. So that's just this little piece here. Okay, so let's use our formula. Area of a sector is 1/2 r squared theta. So area equals 1/2 r squared theta. All right, so what can we plug in for r? So r is just the radius. The radius is 2, so 2 squared. And then theta is the degree, but it has to be in radians. So what's 30 degrees in radians? That's pi over 6. All right, and if you guys work that out, they want us, let's do exact form and decimal form. So 1/2 of 4 is 2 over 6 is pi over 3. So this would be pi over 3, what's our units? Feet squared. And then if they want it as a decimal, you would actually just type it all in. So 1/2 times 2 squared times pi over 6. And as a decimal, it would be 1.047. 2 decimal places, so 1.05 feet squared. Okay, so depending if they say exact or rounded, those are both fine. Okay, example 2. A child is spinning a rock at the end of a 2-foot rope. So he's spinning a rock at the end of a 2-foot rope. Okay, so the radius is 2, spinning in a circle. The rate is 180 revolutions per minute. Find the linear speed or the linear velocity. Okay, so we're going to use v equals r radius times angular velocity. So one thing, guys, when you're plugging in the angular velocity here, make sure you convert it to radians per time from revolutions per time. So let's start with that. So for this angular velocity, it's 180 revolutions per minute. But we need to convert that to radians per minute. So what's the conversion from revolutions to radians? Here. It's 1 revolution in 2 pi radians. All right, so if we do some canceling, the revolutions cancel, and if we multiply across, the angular velocity is 360 pi radians per minute. Okay, so that's going to be our angular velocity. And then what are we going to plug in for the radius? That's 2. So now the linear speed is going to be 2 times this angular velocity. So final answer, let's just leave it in exact form. 2 times 360 would be 720 pi radians per minute. That would be your final answer. All right, thanks for watching, guys. I know that was a lot of stuff. We get to practice all of this in class the next day. Thanks for watching.